Welcome back, everybody. Today we have the second teaching about the pituitary gland. We are again in the endocrine system, and we are going to see the master gland, the pituitary gland. Let's see why the master gland is called in that way. So the pituitary gland, here we have some anatomy. Now let's go through the anatomy itself first. Here we go. So the pituitary gland or hypophysis is in the brain and is attached under the hypothalamus in a little cell. Okay, tiny, size of a pea, and is oval shape, and it has two parts, the front, the anterior, and the posterior lobe. Okay, because its role in activating all the other endocrine glands, so all the rest of the endocrine system, it's called sometimes the master gland. Okay, we see here why, and let's see how the hypothalamus does that, the pituitary gland does that, with releasing hormones, inhibiting hormones, or a combination of the two, inhibiting and releasing hormones. We saw that in the first teaching lesson of the endocrine system. We have 7 different types of hormones released from the pituitary gland, from the anterior lobe: TSH, ACTH, FSH, LH, PRL, GH, and MSH. Now, don't you worry, we're going through each of them. Okay. TSH, let's make it bigger, here we go. TSH is released in response to thyrotropin, releasing hormone, TRH, from the hypothalamus. As circulating concentration of thyroid hormones rise, the rates of TRH, thyrotropin releasing hormone, and TSH production decline. Okay. Then we have the ACTH. The ACTH release occurs under the stimulation of the corticotropin releasing hormone, CRH, from the hypothalamus. A rise in the glucocorticoid levels causes a decline in the production of ACTH and CRH. Is a negative feedback mechanism again. Let's see the next one. Okay, we have the FSH, and as we represent here, FSH has a different function in the body depending on if is releasing male or female. So in females, FSH promotes the follicle and eggs development and stimulates the secretion of the estrogens, steroid hormones produced by ovarian cells. In males, FSH supports sperm production in the testes. A peptide hormone called inhibin, released by the cells of the testes and ovaries, inhibits the release of FSH and GnRH through a negative feedback control mechanism. We see that that's a trend. A lot of hormones act differently based on the gender of the person that is receiving the releasing hormone. Okay, LH, luteinizing hormone. Let's make it bigger. Here we go. In female, LH induces ovulation. It also promotes the secretion by the ovaries of estrogens and progesterone, such as progesterone, which prepare the body for possible pregnancy. In male, LH is sometimes called interstitial cell stimulating hormone, ICSH, because it stimulates the interstitial cells of the testes to produce sex hormones. The sex hormones are called androgens. The most important one is the testosterone. LH production, like FSH production, is stimulated by GnRH of the hypothalamus. Estrogens, progestin, and androgens inhibit the GnRH production. So I'm aware that there are a lot of names to remember. Don't you worry, in your handbook you will have an handbook, a resume of all of them. Now let's go on and see the PRL, prolactin. Here we go. So prolactin works with other hormones to stimulate mammary glands development. In pregnancy and during the period of nursing following delivery, PRL also stimulates the production of milk by the mammary glands. Prolactin effects in human males are poorly understood, but it might help the androgen regulation. Circulating PRL stimulates prolactin inhibiting hormone PIH and inhibits the secretion of prolactin, releasing the factor PRF. Next one, we have the growth hormone, the one that all the sporty guys loves. So stimulating GH stimulates cell growth and replication by accelerating the rate of protein synthesis. So that's very crucial. Every tissue is sensible to it, but especially skeletal muscle cells and cartilage cells are particularly sensitive to growth hormone. Okay, the stimulation, let's make it bigger so we can read it on. Okay. Growth hormone involves two mechanisms, indirect and direct. Okay, I'm not gonna through all the details here. Again, you will have that in your handbook and you can study it more deeply in the handbook. The melanocyte, so that's a very interesting hormone because it's a very different function based on the age. So MSH stimulates melanocytes in the skin to increase the production of melanin. The MSH producing cells of pituitary gland in adults human are virtually non-functional, so it's not working essentially. And the circulating blood does not contain MSH. However, the human pituitary secretes MSH during fetal development, in young children, in pregnant women, and in certain disease that we're not going to do that now, but can be very interesting to see people that are turned also without being exposed to the sun. Now we move from the anterior to the posterior lobe of the pituitary gland. We have ADH, the antidiuretic hormone, and OXT, or oxytocin. And here we go. So ADH, let's make it wide, here we go. The antidiuretic hormone, also known as vasopressin, is released when the body is low on water, so when we are in vasoconstriction. Stimuli for its release include a rise in the concentration of solids in the blood or a fall in the blood volume pressure. The primary function of ADH is to decrease the amount of water loss in the urine, with the loss minimizing any water absorbed from the digestive tract, will be retained and reducing the concentration of solids. ADH also causes vasoconstriction. Sorry, yes, it's causing vasoconstriction more than responding to vasoconstriction. Sorry, that was an imposition. Okay, oxytocin, OXT. In women stimulates smooth muscle concentration in the wall of the uterus during labor and delivery, and in special contracted cells associated with the mammary glands. In the milk, let down reflex oxytocin secreted in response to sucking triggers release from the milk of the breast. In men, oxytocin stimulates smooth muscle contraction in the walls of the sperm duct and prostate gland. Oxytocin levels are known to rise during sexual arousal and peak at orgasms in both sexes, although the function in sexual activity remains uncertain, so it's not yet clear. Okay, now we have a lovely slide with a recap. I just put it full screen. Here we go. So you can see that there is a lot ongoing with the pituitary gland, with the front and the posterior lobe. The anterior and the posterior lobe. Okay. Now, here we go. Perfect. So the information to take on. The hypothalamus produces regulatory factors that adjust the activities on the anterior lobe of the pituitary gland, which produce 7 hormones. Most of these hormones control the other endocrine organs, including the thyroid gland, adrenal glands, and gonads. It also produces growth hormone, which stimulates cell growth and protein synthesis. The posterior lobe of the pituitary gland releases 2 hormones produced in the hypothalamus. ADH restricts water loss and promotes thirst, and oxytocin stimulates smooth muscle contraction in the mammary glands and uterus in female, and in the prostate glands in males. Okay. Okay, this is it for today. We have saw the anatomy of the pituitary gland, frontal lobe, posterior lobe. We see all the way that the pituitary gland works with the releasing hormones, inhibiting hormones, and the combination of the two. And we saw all the 9 different types of hormones, 7 and 2 releasing from the anterior and posterior part of the pituitary gland. I leave you with the bibliography, and I thank you, and see you next teaching.